So you have all of them. You want one. Okay. So I think the way I had intended this to work, and there's nothing wrong with this, but and this is good because it uses the switch, and this is also good that it uses the divider. Like he's pulled this out into a variable, so he doesn't have to repeat himself a lot. That is they call it dry, the dry principle. Do not repeat yourself. So the code is drier when you don't repeat yourself. So so that's good to use the divider here. I think I had intended this to work something like this. But shame on me for not making it more exact.
Put one up.
Yeah, it was right here. Okay, this is kind of what I had envisioned here. But it's the same idea, right? I just did the scan in a different place, but otherwise exactly the same code. And so pretty straightforward. I think the trick here, I just wanted to, is that strings are just, I mean, if you're trying to think of, oh, I need to write a loop to like generate the string or whatever, you don't have to be clever. You can just copy and paste, that's okay. These are strings. And so whatever you put in your code is going to be shown to the end user. And so particularly when we do a lot of HTML, it's about getting the result right and not necessarily about how you got there. So if it's easy to do this, just do this. You don't have to be clever about how you do the formatting. You can just do it really simple. Okay? Everybody following that? So that's the basic idea. Any questions about how this works? I mean, it's very much the same. It was just using the printf and more strings. Okay. I will show another. I'll walk through the HTML one. Okay, with you guys. So let's. I think a lot of people had confusion about the folders and stuff, so I want to go over that again. So I have open here source. And then I have a bunch of folders, you know, there's a GitHub and other things. And then I have examples, right? And so every time you make a Go program, you want to make a new folder for that Go program, okay? And that folder will be the name of the resulting binary. That'll be the name of the program. So if I create a new folder, and this will be, you know, miles to KM HTML, which is a really long name, but it'll make the point. And then I make a main.go file. Right, and then I put this in here, and now I can go install examples / miles blah blah blah, and then I can run miles to KM HTML. Okay, everybody follow what I'm doing here? The name of the folder is inside of examples, so I have to have the full tab here, and then it's the name of the executable. Now it's red because Fish is telling me that it doesn't exist, but it will exist when I run the command. So now it's running it. So, and now when I do this, no, it's blue because it exists now. Every time you run go install, it's going to recompile it, recreate that executable. For most of you guys, you should not be using semicolon, you should be using ampersand. Okay. But otherwise,
most of us, you mean like for
use bash. In bash to run to the two commands, you use ampersand. But anyway, this is the same as just running go install and then miles to. That's all I'm doing. I'm just doing it in one line instead of two.
Bash works with semicolon too.
Yeah, he was having issues with it, but it's, yeah, anyway. I think if it fails, the behavior is different. So we want to change this. If you look at the second part of the question, I have this second problem. Modify the above program so that it generates HTML instead of text, okay? For example, that would be what we want to generate. Okay, so the point here is that this is why I said that strings are something we use a lot in web development. This is basically what we do on the server, is we generate HTML, okay? And so we haven't started a web server, or we're not in the browser yet, but this part of the process is very much like what we'll do later. So that's why I wanted to show you, okay, we did the ASCII art version, you know, we feel like we're from the 80s and we're entering commands and stuff. But we can also generate HTML, okay? So let's try to do that. So the way we're going to do that is basically the same, right? So instead of divider, so I'm going to take out these options just to simplify. And we're just going to use the one case. Okay. And so we need to print, the first thing we need to print is the doc type, HTML, right? And then we have HTML, and then the head. I'm not going to put anything in the head. And then the body. And then we're going to have a closing body. And then the closing HTML. And so far, so good. Okay, so that's going to be the basic structure. And then inside of the body is where we're going to do all the things we want to do. So this is where comments can be helpful. You know, get the number of miles from the user. And so then we're going to scan it, and then we're going to print it out, right? I'm going to use printf, okay? And we're going to say miles, colon, and then %f, and then BR for break, line break. This is HTML. And then we'll put the number. So let's see what we get when we run that, okay? So now it's expecting me to enter a number, and then it prints it out, okay? So actually, maybe we should scan the number before we generate this bit, right? And I can show you another thing we can do. Let's see. And then we're going to want a new line here, just to make it easier to read. So now I enter the number. Okay. So this is the first part, and then we can put the kilometers, right? The way we do the kilometers is pretty much the same way. What was the MIT? And there we have our HTML. Okay, so we've generated HTML. Okay. So I'll show you a few things you can do from the command line. One is output redirection. So
Could we look at that code for one moment there? You might flip it back to the code. I just want to.
yeah, so this I'm just printing out text, and then I am printing out the numbers formatted, and then I'm printing out the closing bits. Okay. So this is a common way of generating HTML, just the strings. Okay. So inside of our strings, you can see the HTML, but outside we have Go code. Right. Okay, so everybody following? Anybody have any questions about that?
You no longer, or you're not using your divider anymore.
No, because now we're in HTML instead of ASCII. Okay, so we're generating output to the terminal. This bit here is the output we generate. We can redirect that to a file, okay? So we can save the output to a file. And so what I'm going to do is do that. I'm going to save it to /temp/ we'll call it km.html. And then I enter a number, and I get no output. I don't see anything. So what happened is it put it inside of that file, inside of /temp/km.html. So this is the tag, posting right angle bracket. So that's how you do redirection. And if we look at that file, so if I do lstemp, notice there's a km.html in here. That's the file I created. So if I use cat, which will read that file and display it, I can see that I have my HTML. Okay? So here's the cool thing is we can open that file, right? Does open work? There we go. So you could generate your HTML, save it to a file, and then just read it in your browser, and you'd be able to see it. Okay? And so this is like the step one of web running, right? It's not a server running. I'm just doing it static. I'm doing it one time, generating HTML. It turns out this is a very popular way of doing web development today. It's become more popular than it used to be. We used to use lots of servers to generate HTML on the fly. A lot of people now, they just do static sites. Okay? They generate static HTML. That's their site, they upload it, and then they use JavaScript to connect to a server. Okay? So the pattern I just showed you turns out to be a very common way of doing modern web development. I run my program to generate HTML, save the HTML, and then I just use a static page. So you could write an entire program just doing it this way. We will see later better ways of making this because this is kind of clunky to work with. Go has a templating library which makes this a whole lot easier. But this is perfectly adequate for what we're doing. Any questions about?
Yeah, I want to see the steps to print it out and put it in the browser.
Yeah, so I'll do that again. So I say go install miles to km.html, that miles to km HTML is the name of the executable. That creates the executable called miles to km HTML. Okay? If I run that, I get the output here. So if I run that and use the right angle tag, I can redirect the output to a file. I'm going to put it in /temp/km.html. So that's going to take this text I generated and put it inside of a file. It still wants me to enter a number. I don't get any output because it's been redirected. Okay? And now I have a file on my file system.
What's cat again?
Cat will read the file and display it. It just dumps it to the terminal so we can see what's inside. You can do that with any file, right? I can cat examples miles main.go, and there's my main file. So the cat is super useful. So yeah, I have this, and then I can use the key open. This works on Mac. I don't know if it works in Windows. You can always just browse to the file in Windows Explorer and just open it that way. That's perfectly fine. And I don't have to actually run that again. I can just hit Command-R and refresh, right? Because it's file : / /temp / km.html. So I can just refresh the page to see the changes, and I'll show you that. I can say, put an exclamation point, and run my all-together one. Oh, yeah, that's a number. And then I refresh and look at added the exclamation point. Everybody following that process? No, you're not following?
Well, I think I missed something.
Oh, okay. So
I'll get it.
we generate our Go program, we compile it, we run it. Our program generates HTML, we save that HTML, and then we look at it in our browser. Okay? Another change I want to make to this program is this scanning the number is kind of cumbersome. So we can use, instead of pulling data in from standard in, where the program runs and then you have to enter the data and hit enter, we can pull in data from the command line as arguments, okay? And that would be more typical of this kind of program. So the way you would do that is you can look at the OS package. So let's go there, go.org/OS. And in here, there is an args. Right here. We will see what that means in a second, but we have these args, and that's how we can get what was passed into the program. Okay, so I can use import OS. I will. This is where we can use our I2A. No, A to I. A2I. Converting an integer, or sorry, a string into an integer. Actually, I went float, don't I? Parse float takes. And so I'm gonna read the first argument and then parse it as a floating point number. So it takes and so number error colon equal that, and that gets our number. So instead of reading it from the user using scan, we use it this way. And then if error is not nil, there's a bunch of things we could do. I'm just going to panic. This isn't necessarily the best thing to do. It's just the easiest. Okay. Right, I got it. Okay. So if you're not familiar, I'll show you real quick what command line argument looks like. So we have the name of our program, miles to km HTML, and then we can pass it arguments. So I can give it a number, 43. Okay, and that's how I'm going to read that number. Okay, so OSRs1 is going to give me that number.
Why is that not zero-based, or what's the
It is zero-based. The zero entry is the name of the program. But it's going to give me that string. And so basically the space is separating the arguments. So it's going to give me anything inside of that string. Okay, so it's going to give me 43. I'm going to convert it into a number, and then I'm going to use the number that way. Okay? So let's run that and make sure it works. Oops. And then we go to our HTML and look and see if it changed. Let's use a different number. There we go, 60 is really small. So that's another way we can get arguments to our program, okay? So actually the Go program itself is implemented this way, okay? It looks for the first argument you pass to Go. That's the command, like go run, go build, go install. It's going to get that as a string. It's going to have a big switch statement. It's going to say when you use install, do this. When you use build, do this. And so that's how we can build a program using command line arguments. This is easier than using the scan line, right? Because I don't have to like wait on user input. It immediately runs. So to show you the error case, what if I don't enter a number? I enter text. That's what happened. And the reason this happened is because parse float, bad values, and valid syntax, and I panicked. In my code, I said panic if an error happens. So if error was not nil, and if there was an error, then just panic. And that's what we saw there. Okay? Usually you want to do something better. Like for example, there's a log package. You can do like that. And then, nice to me, I'll log it as the date. That's kind of useful. But there's other ways you could do it too. You could, if you've seen a lot of like Unix programs and stuff, they'll show you help if you do the wrong thing. Like when I use Go and I say go blah, which isn't a real command, it tells me unknown subcommand blah, type go help for usage. We could do that on error or whatever. So that's the other way we can read command line stuff. Okay. All right. So
We take a pause.